Hello geometry students, today we are going to continue 10.3 section 10.3 using chords. So we're going to do question number 1 through 8 from Big Idea Student Journal. So very first question here, in exercise 1 through 4, find the measure of the arc or chord in circle Q. So we have to find these four things: arc or chord. So arc will be when you see this symbol on the top of the name, and the chord, there would be nothing. So very first one is measurement of arc WX. So if they're talking about, we see this symbol here on top, it means we have to, this is about arc. We have to find the arc measurement. WX is here, and as we know from our previous section how to measure an arc, that's always the angle inscribed at the center. Whatever the angle is here, that's the measurement of this arc. I have to know how much is this one, and for this, when I look it carefully, I see this is same as this one. And why are they same? Because that angle is vertical, those angles are vertical. So if this is 42, I could say this is also 42. This is 42 degree. If this is 42, so my arc is also 42 degree. So I could say measurement of arc WX is equal to 42 degree. All right. Why? Because I know how I got it, because measurement of angle WQX is equal to measurement of angle ZQY. And why is it? Because they're vertical angles. All right, and they're going to be congruent. Let's move to the next one. Next question is we have to find YZ. You see there is arc is not drawn. So if the arc is not drawn, it means this is not, arc symbol is not drawn, so it means they're talking about chord. It's chord YZ. Where is YZ? YZ is this one. They want you to find this one. All right, and we know already one theorem, that's called congruent corresponding chords theorem. That's congruent from our 10.2, congruent corresponding chords theorem. Corresponding chords theorem. For your information, it is in section 10.2. You can check it over there. With the help of that theorem says if the arcs, congruent corresponding chords, if the chords are congruent, then their angles, the arc measure is also the same. So I know that this is 42 here, this angle is 42, so this is 42 degrees. So I know the arcs are same. So this is 42, this is 42. It means the chords have to be congruent. What I mean this is same as this one. So they're going to be same. So my answer would be YZ is equal to 3.6. YZ is 3.6. That's my answer. All right, let's move to the next problem, question number 3. That is, we're supposed to, so no arc symbol on top means I have to find chord WZ. WZ is this one. This one I have to find, and I know that whatever the angle is, this one is same as this one because they're vertical angle. So whatever this arc measure is going to be the same arc measure. So it means the same arc measure, I could say that the chords are going to be congruent. So I would say WZ is what? 9.2. The same thing, congruent corresponding chords theorem. So it's congruent corresponding chords theorem. Corresponding chords theorem. All right, let's move to the next one. That is, here we have to find, so we see the symbol here xy, it has a symbol on top, xy arc. Where is xy? I have to find this is how much. And we already talked about that this angle is 42, and I know this is a straight angle, this whole thing is 180. And if I just want to, so let me erase the remaining part, you don't need it. Let me erase it so it becomes, you can easily understand it. Okay, so here I know that this is 42. I need to know this angle is how much. This angle will help us to find the measurement of this arc. And if I know this is 42, so how much is this? Because the whole, this angle is 180. So this is going to be what? 180 minus 42. You have to do that. So here it's the same thing. When we do it, that's going to be 180 minus 42, and that's going to be 132 degrees. If this is 132 degrees, it means this arc is also 132 degrees. That's it. Let's move to the next page. We have a question here that says for question number 5 to 6, we have to find the value of x. We have to find x. It means we have to somehow use some kind of theorem to apply so that it becomes, we can solve it for x. For both questions, the theorem we are going to use is perpendicular chord bisector theorem. Perpendicular chord bisector theorem. All right, so that's already in your 10.3. You can, so that says if it is perpendicular, then it's going to bisect the other chord if one chord is a diameter, or if it is bisecting, then it's going to be perpendicular, vice versa, both ways. So from here I know that PT is congruent to TR. They're congruent. All right, so I can just substitute and make them equal to each other. 2x minus 4.1 is equal to x minus 0.5. You just solve it, subtract x from both sides, so you get x minus 4.1 is 0.5. Now add 4.1 both sides, you get x is 4. Subtract, yeah, so you get at 4.1 both sides, so you get your answer is going to be 3.6. That's your answer. All right, let's move to the next one. Next one here, same thing, because this is a diameter. Let me repeat it. It's a diameter and it is perpendicular to one of its chord. This is perpendicular, so I can finally say this is congruent to this one. The chord is going to be bisected. So I would say GH is congruent to HA. They're going to be congruent. I can substitute. So I can say 3x minus 5 is equal to 2x plus 1. And when we subtract 2x from both sides, that is x minus 5 is equal to 1. Add 5 to both sides, x equal to 6. So keep in mind, this theorem is used in both problem, perpendicular chord bisector theorem. All right, let's move to the question number 7. Question number 7 and 8, you have to find radius. All right, I have to find radius. But when I look at the picture, I don't see any line which is forming a radius, so I have to assume a radius here. That's the radius. All right, that's a radius. I have to find that. So it looks like this is a kind of right triangle here. where it is 90°. If I somehow get both legs, I could easily find my radius. So this one leg is given 3, that is 3 here, but I have to have this part somehow. But when I look at one of my theorem, that is called equidistant chord theorem, equidistant chord theorem, from this section, that says that if it is equidistant, then the chords are going to be congruent, or if equidistant from center, then chords are going to be congruent, like it is this thing if they're two chords. And if they're equidistant from the center, if they're equidistant, then this is going to be same as this one. Or if these two are same, then they're going to be equidistant. So that we have to apply here. So let's apply. So in that case, I know when I look at the given values, I see that this 3 is same as this 3, means this is congruent to this. It means our chords are also congruent, so that will help us to decide. So I know here that BP is PE, that is 3. That means our AC is congruent to FD. They're going to be congruent, and the moment I know they're congruent, I can set up my equation, and I would be writing down 5x minus 2 equal to 3x plus 2. Subtract 3x from both sides, you get 2x minus 2 is 2. Then add 2x to the both sides, you get, add 2 to both sides, you get 2x equal to 4. Divide by 2, you get x equal to 2. You got your x, but that's not your final answer. You're supposed to find radius. So one thing we know by perpendicular chord bisector theorem, we know by perpendicular chord bisector theorem, that if the one is kind of, this is diameter, if I assume I extend it both sides, this is going to be a diameter. So this is perpendicular to one of the chord, means it's going to be bisecting the other chord. So the total, I need to know how much is that. So if I have to find AC is how much, I can plug it in my x. So AC is 5x minus 2, that is 5 times 2 minus 2, that is 10 minus 2 is, we are going to get 8. But I have to find BC. BC is what? Half of AC. All right. It's the, because perpendicular chord bisector theorem, so 8 over 2, that's going to be 4. So I have to now just look at this triangle here, the triangle, this one. That's a right triangle. I can use Pythagorean theorem, and when I apply Pythagorean theorem, that says the leg square, add them, it's equal to the square of hypotenuse. So hypotenuse, this is the hypotenuse, and this is leg, and this is leg. So I would say that CP square is what? Square root of BP square plus BC square. We plug it in. BP is what? 3 is given, and BC we already got 4 square. That's 9 plus 16, square root of 25, and that's going to be 5. So CP square. So let me just remove this because I already took the square root here. So our CP, and that is what? Our radius. All right, that's our final answer. This is our final answer. Same way we can do the other question, the last one. Last one is here the same way. I have to imagine a radius here, so I would draw it here. That's my radius. That's R. So same thing, I need to know how much is this, I need to know how much is this, and I can see this. I can say the same way by equidistant chord theorem. By equidistant chord theorem is same as the last question. I know there it was shown that the chords are equidistant from the center, but here this time they tell us that the chords are congruent. If the chords are congruent, then I could say they're going to be equidistant from the center. So this is going to be congruent to this. So I could use it here. So I could say that OY, let me write down the other expression first. Yes, I could say that UV is equal to WX. They're same. It means OY is congruent to OZ. They're going to be congruent, and I can finally write my expression. 4x minus 5 is x plus 4. You just simplify that. You subtract x from both sides. You get 3x is 3x, and add 5 to the both sides. You get 3x is 9. Divide by 3. You get 3. X is 3. We got our x. So what we can do, we can finally just plug it in one of the expressions. We are going to plug it in here. So that's going to be 4, and then replace this x by 3. So I can get my OY. OY is what? OY is 4x minus 5, and that is 4 times 3 minus 5. That is 12 minus 5, and that is 7. I got OY is 7, but that's not my final answer. So I know that this thing is 7, and also I know this is perpendicular to this chord. This is perpendicular, so this is going to bisect this one. So this whole UV, so same thing, again we are going to use perpendicular chord bisector theorem. Perpendicular chord bisector theorem, where I can say that OY is perpendicular to UV, so it's going to be bisected. So U, or if I want to find YV by V is equal to half of 20. That's going to be 10. So I got all the two legs. I have to just find the radius. So I could say OV, that's actually the radius here. OV is equal to square root of the sum of the squares of the legs. The one leg is 7, that is OY square plus YV square. Just plug it in. OY square is 7 square plus 10 square. That's going to be 49 plus 100, and that's going to be 149. And when you round the answer to the nearest 10, because it's not a perfect square, your answer is 12.2 rounded to the nearest 10th. So if you're rounding, so always write down what you get, rounded to the nearest 10th. So that's your final answer here. This is your radius that you required for the circle. Okay, all right, I hope you get it. If you have any question, leave it in a comment box or loop mail me. Thank you so much. Stay healthy. Bye.